Hello, everyone. Today, we're going to be addressing the needs of the high-performing student, Part 3. I'm Kim Langen, the CEO and co-founder of Spirit of Math. In this section, we're going to be looking at developing the strategic thinking and skills and strong reasoning by problem solving, and I'm going to show you sort of an idea of linking one concept to the other, and then to develop a multi-year problem solving program. First, let's look at how we develop strategic thinking skills by using problem solving to link one concept to the other. So here's the first question from a Spirit of Math contest, grade 2 question. Brian Bunny is reading a book called How to Grow Your Own Carrots. If he starts reading at the top of page 8 and he reads to the bottom of page 20, how many pages will he have read in all? Basically, the question states that Brian Bunny started at the top of page 8 and went to the bottom of page 20. We often get this answer and usually when I ask why they did it, why they answered it like this, a person will say, well, because you add the extra one because it works. So I usually say, well, there's got to be another way to do this so that it's not just adding an extra one. So we actually look at a different way to reason through this. I'd like to now go through the question again. Brian Bunny started at the top of page 8 and finished at the bottom of page 20. A book does not start at the top of page 8, so the whole picture has not been stated explicitly in the problem. So we need to look at what's the whole picture. Often it is what is not explicitly stated that is a clue to the problem. Good problem solvers will realize this and think about the whole picture. So in this question, the important part of the whole picture includes the pages that were not read before page 8. The pages in the book after page 20 don't matter for this question. Now, let's solve this question again. If Brian Bunny read all the questions from page 1 to 20, then he would have read 20 pages. But he didn't read the first 7 pages, so he read all 20 but the first 7, or 20 minus 7 pages, which is 13. Yes, the answer is the same as in the top equation, but the logic and the reasoning is different, and that logic can be applied to other problems. Before I go on, I just want to make a quick note. We use Brian Bunny and his book for younger ages as it is very concrete and young children can relate to them. Brian Bunny and his book on how to grow carrots is also rather fun for kids. Now let's look at the problem that could be introduced in grade 7, the number of numbers in an arithmetic series. Some conceptual understanding, as you will see. The same conceptual understanding is the same as the questions that we just did with the book problem, except we don't have Brian Bunny reading a book that started at page 8 and went to the bottom of page 20. Notice instead of pages, there is an algorithm. The numbers start at 8 and go up one by one to 20. So the same reasoning and logic can be used. There are 13 numbers because we have 20 minus 7 numbers that come before 8, giving a total of 13 numbers in this series. So you see how just starting with a younger grade with the proper reasoning can help to develop a proper understanding of the mathematics that's happening, and you're not just using equations. Adding some complexity to this thinking, we can skip numbers. So how many numbers are there in the following arithmetic series? The last number before 12 would have been 10. So you would subtract 10 from 44 to get 34 numbers. But every second number is missing. So this is twice as many numbers as there actually are. So you divide that by 2 and you get 17 numbers. You can also go further than this by adding the concept of the mean average, and then show the kids how to think about this in an arithmetic series so that they can calculate the sum of a series by reasoning their way through it, rather than relying on equations. In fact, students will be able to create equations because of their reasoning if they wanted. In this case, we're going to define the mean average as the same as taking all the presents and giving everyone an equal amount. Now, this concept for young children is really nice because they like presents and they like to have that equal amount in the fairness concept. So we take some of the gifts from the people who have the most and give them to those who need more until everyone has the same number. So the average is 3. Now, once we do that with an arithmetic series, we can show the kids how to make it the same, all the numbers the same, which is the average. And then from there, we've got, we can figure out the sum of the series. Now, I'm going to go into a different type of question so that you can see some other ideas to think about when creating good, rich problems and how you can make them, why they are so important. So in this question from grade 4, and this is another example to illustrate the richness of questions and the skills that are learned beyond what we would term as just mathematics. Many people say, well, this is a math question simply because it has triangles in it. Well, maybe, but there's more to this because the mathematics and the mathematical thinking that's required to solve this problem isn't just a randomness. So how many triangles of all sizes are there in this diagram? Most people will start this question by randomly counting. Then they realize that they may have counted a triangle twice, or they realize that a triangle can be many different sizes. We introduce this to children at a young age so that they can learn how to organize their ideas and organize a lot of data. We would like the skill of organizing data in a logical way to become a norm for kids. So let's look at the solution. First, we need to be able to keep track of all the different triangles. So the regions are labeled in a logical way, starting with A through to H. Then we teach the kids how to create a chart and determine the triangles with just one region, 2 regions, and so on up to the maximum number of regions in this question of 6 regions. Then you can all add them up. Now we realize that some of these regions may not be triangles, but you can form this chart and you will see that then if it was a 1-region triangle, A is not, but B, C, D, E, F, G, and H are. So there are 7 one-letter triangles or 1-region triangles. And then you can make a triangle with 2 different letters. So an AC is a triangle, and not AB though, but AE will also be a triangle, a 2-letter triangle, and so on, as you can see in this chart. There are no 3-letter triangles in this particular question, but there are 4-letter and 6-letter triangles. So there are a total of 14 different triangles for this answer. Now, this may seem very simplistic, yet these skills of organizing and tabulating the data in a table and logically going through it from the letter A onwards is critical for all data analysis. All the way up to the workplace as an adult, you will see this. Now let's look at how we thought about when developing the problem-solving program of Spirit of Math. I hope you can use some of our ideas to establish a solid program for your kids so that you can create a year-long problem-solving program. So let's go and see what we looked at, and hopefully this will help you. First of all, the very first critical stage is that you establish a purpose for each year, other than just doing problems to do a problem. For example, in our younger years, we prepared very specific questions that gradually develop reasoning from very simple if-then type of reasoning to more complex series of reasoning. We also spiral the types of problems and logic so that the students work with the same type of questions, with the same type of reasoning, but incrementally increase the complexity each year. For example, in grade 1, we ask this question. There are two faces below, Andrew and David. One is not Andrew, who is the other? Typically, many people will quickly answer David, which is not the correct answer. Kids have to learn how to use if-then, then-this logic. If one is not Andrew, then we should look at David. But the question then asks, who is the other? As we look at David, the other one is Andrew. Andrew is the correct answer. The if-then logic is used twice. In later years, we will use the double negative and add in other questions, such as before and after questions, for a date problem. For younger children, look for these types of questions that integrate some basic logic. Focusing on a purpose other than expanding on specific types of questions from specific topics in math allows you to develop other skills which are critical in developing mathematical thinking. For example, for Spirit of Math grades 5 and up, the purpose for every grade is different. In 1 year, we will focus on flexibility and the ability to determine the type of question. So we want to make sure that they have an exposure to many different types of questions using the knowledge and skills from all topics expected for that grade. Another year, we may be really focused on time management, how to get through the many questions in a specific amount of time. In other words, how to prioritize their time. Other skill sets, another purpose, could be the grit and persistence and attention to detail. Few questions that don't necessarily require many math skills, but do require advanced reasoning to figure out how to get into the question. So now we don't give a lot of different questions, but we will get a few to establish the grit, persistence, and the attention to detail. Finally, you can have a purpose just to develop math skills, and your problems may be there to consolidate the skills and take the skills to a whole new level. The purpose leads to the types of questions and the number of questions that you will be providing to your students. For example, in grade 5 at Spirit of Math, rather than having a couple of problem of the week questions, we switch it up to larger assignments so that they can learn how to prioritize their time and learn to work with many different types of questions, gathering up their knowledge and honing their skills taught throughout the year and from previous years. In addition, they do have a problem of the week each week to introduce them to different types of thinking. They have an opportunity to work with others to get the answer, and if they get a correct answer, then they will receive a bonus point on their drill for that lesson. If they do not get the correct answer, then they lose nothing. This helps the students to take risk. In grade 6, the number of questions to complete in a specific time increases and the types of problems becomes more complex for the final large assignment. The grade 6 students get 3 of these assignments during the year. In both grades 5 and 6, the types of questions would be those in the first and second sections of the contest. Because there are so many questions, they are fairly easy and they don't require an intensive amount of reasoning. They are more skill-based questions with reasoning and logic included. We may throw in 1 or 2 of the C level or the last type of questions in a contest. In grade 7, the problem-solving component consists of 10 questions per month, not 120 like grade 6. The questions don't require an advanced mathematics ability, but they do require a huge amount of logic and reasoning, and then a great deal of grit to get through the problems. These questions are the types that you would see in the last part of contests, plus maybe even harder. As you can see, there is a purpose beyond just giving some problems to kids. The types of problems and the number of problems will develop different skills and thinking. In our Math Problem of the Day books that you can purchase, I have written questions that incrementally build the reasoning from one grade to the next. The solutions work through the questions with logic rather than algebra. Many people have noted that the solutions are not the norm. This is because we listen to our brightest kids, those who get perfect or almost perfect on international contests, and we realize their thinking was different than ours. Their reasoning did not use algebra, and their reasoning and logic was quite advanced. So we took their thoughts and integrated them into our solutions. I hope that helps you understand what to think about, or some things, some little things to think about when developing your problem-solving course. Now that finishes part 3 of addressing the needs of high-performing students. I hope you feel that you can take with you at least one little idea and apply it to your own situation. Once again, our mission is the basis for all that we do: to promote cooperation, inspire confidence, and release the genius in every child. Notice that it doesn't say anything about a specific topic. We believe that the outcome should be about people who have the confidence to attack the most difficult problems, the ability to cooperate with others with humility and compassion, understanding that when two minds come together, a third is created. Once that happens, then their potential can be realized and their unique genius released. Thank you. That finishes part 3 of addressing the needs of the high-performing students. I hope you feel that you can take with you at least one little idea and apply it to your own situation. Very quickly, I'm just going to review what was taken in parts 1 and part 2. In part 1, I covered the definitions and overview of a high-performing student, how that definition differs from gifted, and some misconceptions on how to work with your high-performing child, and some proper ideas as well, and then some resources. In part 2, we looked at specific strategies to use when sitting down with your child, the role of drills to build automaticity and fluency of numbers, how to develop a sense of discovery for mathematics, your language, procedures, and gave you some examples of how you can incrementally develop the procedures so the complex procedures appear obvious. And then finally, focusing on ideas to develop mathematical thinking. And that's it for today. We would love to hear from you. If you have any other topics that you would like us to discuss, then please let us know. Thank you.